Good morning, good afternoon, everybody. So, in the last class, we have to do a DHCP relay that is missing. So, we are going to do a DHCP relay lab today, and followed by that, we have a one parameter, and still it is not covered. That's the only topic we are yet to complete. That is ECN and CWR congestion window reduction and ECN. We'll see the flags and also we'll do a case study for it and in what are all the scenarios where we have to use these two flags and to figure out. So this is pretty advanced topic. We are heading to the advanced topics now. So this is something the prerequisite is to they should definitely understand about the sequence number, acknowledgement number, and the flags or the prerequisite to understand this because we are going into the advanced topics of TCP IP. So I mean maybe I would say 5 6 classes back we discussed about TCP window size, zero windows. So this all together combined, and if you want to really understand this topic, you should have a pretty solid understanding of window scaling factor, zero windows, sliding windows, and how it is used, how this the Windows proposal happens when the TCP handshake is actually happening in the very beginning of the conversation. So you should know about all that to understand this. If you guys have a really good understanding about all the other parameters, and ECN and CWR would be you feel very easy to understand. And that's it about the TCP. So we covered most of the not most of the we covered all the topics in the TCP IP. And as I said, we will do a DHCP relay lab today, and also we'll discuss about DHCP transition diagram, and we will also see how renew works, how a release, and how what are all the packets and the headers we see when we are troubleshooting. What are all the key flags you should concentrate when you're troubleshooting, and you should pay attention to when you're troubleshooting your DHCP. And followed by that, we will be discussing about LACP. It's a link aggregation protocol. It is an open standard protocol. So the equivalent protocol for Cisco is PACP, port aggregation protocol. So since this is a vendor neutral training, we are just doing LACP. So here logically we are bundling the ports and the switch thinks this if you bundle multiple ports. So the maximum is 8 ports if you bundle together, and if you look from the spanning tree perspective, it's going to look at as a single port, irrespective of if you do a port channeling for 2 ports or 8 ports. From the spanning tree perspective, it's going to look at the all the individual ports as a single port. So that's the whole ideology of doing LACP, and we will see the LACP messages, and we will see different types of LACP modes. It has to be running on the primary switch and the secondary switch, or maybe the remote switch, where you're trying to establish your LACP. And if we really have a time to continue, we will discuss about the routing logics. That's very important for data communication. So we will see the precedence of static route, dynamic route, and then again, since this is a vendor neutral training, we are going to cover about static route, OSPF, and BGP. We know RIP is deprecated, but I'll definitely give a good background about RIP. But we all know that that is no more used in the enterprise because of the limitations with the RIP. So we are going to do a deep dive about OSPF and BGP in the upcoming classes. So to start with, let's start with DHCP relay lab. So what are the key flags and what are the key key points we have to look into I mean, when we are talking about DHCP, what are the key values and the troubleshooting steps we have to do? So I will guide you through that when I'm doing the lab. So now let's jump into the lab and let's do a DHCP relay. And I hope we actually did a DHCP, and we have done a case study, and also we discussed about the packets in the DHCP. So hopefully everybody should have a good understanding of DHCP to understand this DHCP relay. Let me quickly open my RDP. So what I did in the topology, no much changes here. Let me take my pen to annotate. So if you look at this particular PC over here, this is configured for VLAN 10 and the fast Ethernet 0/0. I created a sub interfaces, one for VLAN 10 and the other sub interface for VLAN 20. So on the fast Ethernet 0/0, I created .10 for VLAN 10 and fast Ethernet 0/0.20 for VLAN 20. So I created a sub interface on this for you know this is for inter VLAN routing. This is a routed port. So I created the encapsulation.1 queue to enable the VLAN 10 and VLAN 20 on port 20, the logical sub interface. So this is a routed port and this is a router on a stick topology. Let me quickly jump into the CLI of the devices. Let's see the config. So IP interface, brief, exclude, unassigned. So I have created, as I said, fast Ethernet 0/0 is a downlink for the switch 2. It's connected on port 1/5. And I created three logical sub interfaces. One for VLAN 10 for the VPC over here. It's coming from VLAN 10. And the other VLANs for VLAN 20, it's for VPC2 over here. Can I me little bit drag? Yep, this is for VLAN 20. The port fast Ethernet 0/1. This is for VLAN 20, and this fast Ethernet 1/4 is for VLAN 10. Pretty simple topology. And this is for router on a stick. So there is routing happens between different VLANs. So there's a router on a stick topology. Let me hop on to the VPC, the guy over here, VPC. And if I gave show IP, you can see the IPs assigned, and this is a DHCP IP address. So before that, let me show you the basic config, what I did for this, and also give you a quick background about the DHCP relay. So this is one of the most important question in your interview when it comes to DHCP. So when the actual computer, if it goes for the DHCP process, we all know that it goes with there are four packets the PC would actually send. That is discover packet, offer, request, and acknowledgement. We discussed about that. So this is called DORA process. So once the DORA process is successful, only then the PC gets an IP address. We all know about this. We did DHCP labs. So what DHCP relay does and what are the key values you should see when you're troubleshooting in your enterprise, or maybe when you get a capture, what are the key values you have to concentrate to figure out where the problem is. So as I said, it has to go through the four phases DORA process. The DHCP relay is something. Example, in our topology, let's imagine that the request is coming from here. So the request is coming from here. The guy sends the discover packet. So since I created the gateway for this VPC is fast Ethernet 0/0.10 because that's configured with this IP address over here. If you look at this 10.0.0.1, so here's 10.0.0.1. So what happens? It sends a discover message, right? So if my DHCP server is not local, if it is not in the same subnet, so how do I send this DHCP request? Because we all know that the broadcast is limited. The router, it's a boundary for the ARP request. So I cannot just broadcast this packet to everyone, right? So what happens here, discover is a packet, it is a broadcast. We'll see that in the packet capture. It's a broadcast from the layer 3 perspective, it's all 255. From the layer 2, it's all F. This is layer 2 and this is layer 3. So this broadcast, this guy is the inner border of the ARP request. So this is a broadcast domain and this is a collision domain. C stands for collision domain. And the router is a broadcast domain. So what happens here? My broadcast comes here and then it actually travels as a unicast packet. So what I did in this topology, so I told that your DHCP server is somewhere on a different subnet. So I created two sub interfaces. One is for this VPC. As I said, this is on VLAN 10. So the gateway is 10.0.0.1. Over here, if you can see this. So from this VPC, it actually comes and hits this gateway as a broadcast. And what happens from 10.0.0.1, I created a relay address that is called as IP helper address. So this computer is telling that, I don't know where is my DHCP server, but can you help me to get my IP details? I want the IP parameters, right? So if I have the three parameters, my IP address, my subnet mask, and my gateway, if I have these three parameters, first here's your IP, your subnet mask, and your gateway. I need these three parameters to forward my packet in the network. So the request comes in here and it goes as a unicast packet to 20.0.0.11 because we configured 20.0.0.11 as a DHCP server. So from this subnet, since I cannot forward my broadcast to the other network, so it converts it as a unicast packet. Sorry for that. Let me write it very clearly. So the request comes here, 10.0.0.1 as a broadcast. And this 10.0.0.1, it's a gateway, right? So once it hits the gateway, so it carries a packet called a gateway address, GI address packet. That is a unicast packet. And it goes to 20.0.0.11. This is something you should understand. So yeah, when you configure or if you want to reach your DHCP server, the first thing is the basic checks. You have to check your IP relays configured properly. Yeah. And inside your DHCP pool, have you configured your subnet mask detail? Have you configured your gateway details? And everything should be properly configured. Otherwise, because the subnet mask is the key value to determine your network. So example here, it comes from 10.0.0.10 and the subnet mask is 255.0.0.0. So what if you configure somewhere here for this DHCP pool, if I configure, I'll show you the configuration so that's helpful to differentiate better. So run section DHCP. So the subnet mask here, I gave it as /16. And if you go to this gateway, so I gave the gateway as, sorry, I gave the subnet mask as 255.0.0.0. That's actually, we shouldn't do that. Just for your understanding, I shown this, it has to be same because it defines your network. So if it comes from /8, my gateway should also be in a /8 network. But if you look at this, my fast Ethernet 0/0/10 over here, that is the gateway for this VPC device over here, right? And if I go to the DHCP pool, I have configured something like 255.255.0.0, but it is supposed to be 255.0.0.0. And let's see when we do a discover what happens. This is purposely I did for a troubleshooting. So how Wireshark helps us to figure out. So this is a one hop away. But what if your network is something like you have your DHCP pool configured here. You imagine this is your DHCP server. This is a centralized DHCP server, and because that's how the best practice is, always you should have a centralized DHCP server because I cannot have DHCP server for every LAN. That's practically not possible. So what happens here, if I give this device as my DHCP helper, my request just goes as a unicast over here all the way. It is just an IP communication, peer-to-peer communication. In the middle, the ARP happens. We are not bothered about that. It's out of topic here. So it is just going as a unicast packet to this DHCP server. So the whole point is your DHCP server, wherever you configure your network parameters, your DHCP pool, right? It should have a proper IP parameters, whatever you configured on your layer 3, your gateway. So here it's a fast Ethernet 0/0/ fast Ethernet 0/0.10. There is a logical interface I created for this VPC because this VPC is on VLAN 10. Layer 2, this is on VLAN 10. So the basic checks, what else you have to check? You have to check your subnet mask and your gateway, and you have the same configuration on your pool. That is very, very important. Otherwise, your IP communication will never happen. And because what happens, this is going to hand over your IP parameters to this computer, and this PC will assign an IP address, something like that, 10.0.0.3, and the subnet mask could be 255.255.0.0 because I configured the subnet mask as /16 here. But it is supposed to be, it has to be on /8. So let me go to the VPC here. If I give show IP, I see the IP 10.0.0.3 and it is /16. So it is supposed to be on /8. So let me do a DHCP again. So for that, I have to run a command ipdhcp. Before that, we'll run a capture. So here we know the discover packet goes from 1 minute. Let me choose this. The DHCP packet goes from this PC, discover, D stands for discover, right? So let me take a capture on this particular interface. I should see my discover packet. If I go to capture, so let's jump on VPC. If I give IP DHCP, so this is actually good. I mean, in this VPC on the EVNG, it actually shows the DORA process. So your discover process completed successfully. So let me stop this capture. So what happened here? If I open this discover, the dynamic host configuration protocol, my discover packet. So your client IP address is all 0. Let me take my pen quickly. So if you look at this, client IP is all 0. And if you see, I don't know the IP helper address detail, not yet. We haven't found anything. And if you see this, you should see this discover packet, and also you can see your host name. So this helps actually when you take a capture. Example, I mean, in my experience, I'm telling you, we have an info blocks as a DHCP server. So this parameter is very helpful because if somebody is complaining that, okay, my computer is not getting a DHCP IP address, the very first thing you have to drill down this option, and you can see the host name here. Right away, you can spot. So this shows your host name. So what are the key values you should see? So you should see in the option, is it I see the discover packet? Yes. And if you see, I don't see any information because this is a broadcast. If you quickly jump back to the IP header, so all these fields here, you have to concentrate when you look into the DHCP every packet. You have to see your client MAC address, and you should see actually your all IPs would be 0 because this is a discover packet. And at this point, I don't know where is my relay server, where is my helper address, right? Because this is a discover packet. So when you drill down your IP header, and if you go over here, my source IP is all 0, and this is a broadcast. And then if you jump back again to your layer 2, you should see it's a broadcast, and there you can see the MAC address. Yep. So the question is, okay, what if I have a centralized DHCP server? I mean, what if I have a DHCP server over here? If it is an info blocks, or it is if it is an F5 DTM, or it can be a Windows computer, you have to take a capture from the DHCP server over here. So if you have to look at your service port, where exactly you got the services. But in the info blocks, I have seen you have to select your actual DHCP nodes. So that's again the out of topic. So here, when we talk about the capture, you have to take your capture on the DHCP server when you're doing a troubleshooting. So if needed, if there is a problem with the client, and if this DHCP server is actually leasing the IP address to other host, and if there is a problem with the one single host, then you have to the recommendation is to take a capture on the source. So it depends on your scenario. You have to act dynamically. If it is something problem with the actual source, you have to take a capture on the source. If it is a generic problem, if it is a global problem, then you have to take a capture on the DHCP server. So coming back to this, so what is the main impact of this? If you actually see this is my gateway 10.0.0.1. If you see, the subnet mask is 255.0.0.0. But just by configuring the, this is a misconfiguration on the network. So it got a subnet mask as /16 over here, right? You go to the VPC, you can see it is /16. How this is impacting. And if you open the capture, how do you figure out? Okay, I sent a discover. I got an offer message. And here, if you actually see, the broadcast, the request is coming from your client IP address is just proposing this 10.0.0.3, and your relay address at this point, the next server IP address is 20.0.0.11. Why? Because if you again open your configuration on the router, if you look at this, I configured the helper address as 20.0.0.11 over here, right? So it's exactly showing here. So when you take a capture there, it should match everything. So it is proposing an IP address 10.0.0.3 offer message from the server. We know this, we did this. And it is telling that your IP helper address, your actual DHCP server is 20.0.0.11. You have to go there. As I said, this is an unique cast. Yeah. And again, in the request packet, again, it is coming from the source. We know that it haven't picked this IP address, so your client IP address, this one. And if you see all the options over here, you can see the host name, the requested IP address is 10.0.0.3. It comes under option 50, and your gateway is 10.0.0.1. And finally, again, so if you look at this, this is very important. So all this communication is happening between the gateway and the actual device, 10.0.0.1 and 10.0.0.3. But my actual DHCP pool is configured on 20 subnet. Yep. Because if you go back here again on the R1, show run section DHCP. What happened here? I mean, is it the device rebooted? Okay, in the capture, let me open and take a capture here. Okay, so I think it is rebooted for sure because oh, okay, sorry for that. Yep, I'm a bit confused. If I give show run interface fast ethernet 0/0.10, so my helper address is 20.0.0.11. So if you look at this, my actual DHCP server is not on the 10 subnet, right? That's the whole point here. So when you got this DHCP packet, you should not just look into your DORA. You should not look only for discover offer request and acknowledgement packet. You have to drill down every single packet here, and you should see all the parameters are properly configured. As I told you, this is my helper address. And finally the client got this IP address 10.0.0.3, and you can see the lease time. So it's telling that the rebinding time is 21 hours and the renewal time is 12 hours. And the default gateway is 10.0.0.1 and the subnet mask is 255.0.0.0, but my actual gateway is configured with 255.0.0.0 over here. So that's a wrong subnet mask, right? So from like this, you have to spot when you capture your packet, you have to check your config, you have to compare your config, and you have to drill down your options, and you have to see that. And we discussed this before. And additionally, if you configure your DNS options, you should also see your DNS options along with that. So the key values, my default gateway over here, router, option 3 is my gateway. Then my subnet mask value, my renew time, my rebinding time. And if you actually see from the client perspective, it is telling that my DHCP server is 10.0.0.1. That is very important. Only in the gateway we configured this, and this is an unicast packet. All these are very, very important, and you should understand when you're doing your troubleshooting. If you understand this, then you can troubleshoot any kind of DHCP. So once the client got an IP address, so it sends an Cretaceous ARP. It's telling that this is my IP address 10.0.0.3. So this Cretaceous ARP helps us to find the duplicate IP address. So it is telling that generally nobody should, you should not, DHCP server, you should not assign this IP address to anyone else because this belongs to me. It belongs to me because I got this IP address. We discussed about this Cretaceous ARP in the ARP scenarios. And if you see, it is doing a broadcast and it is coming from 68.04. And you can quickly check whenever you get an ARP packet, you have to go to your actual device and you have to compare your MAC address. And if you compare your MAC address, if you look at this 6804, the last 4 digit. And if you go back here, 6804, right? So it sends a Cretaceous ARP once it received. So what are the key options we discussed here? We saw the IP helper address, what is the use of it, and if you configure an incorrect subnet mask, how it is going to impact. So what happened here? So it is telling that now this computer, it doesn't belong to this network, right? Because my subnet mask is totally different. It is /8, but it is supposed to be /16 over here. Sorry, it is /8, but my DHCP pool is configured as /16. So this PC never belongs to this network. It's totally different. So that these are all the implications when you misconfigure your DHCP's pool, irrespective of any vendor device. This is the base logic of doing the DHCP and troubleshooting. So now, what if there is no DHCP server configured? So if I go to this VPC2, let me hop on to VPC2 IP DHCP. And then if I go over here, let me close this capture. On the VPC2, I'm generating a traffic, and this is on VLAN 20. I don't see any traffic. So the basic checks, let me go to the switch. So the very first thing, whenever you're doing a troubleshooting with your switch, you have to first check, do I see the MAC address? Because your actual packet is always, it is going through the switch to any device. It is going through the switch. So it should actually mark your incoming and outgoing MAC address, right? So it should label every MAC address, because if my communication is happening to this device over the layer 3 communication, it has to go through the switch. It has to send the frame, and the switch has to learn the MAC address. Show MAC address, VLAN, show MAC VLAN 20. So if I go back to this VPC and if I give show IP, show IP, and this is telling that 6808. But if you see over here on the VPC2, sorry, on the switch 2, it is giving some bogus value here. It is self. This is not dynamically learned. So what should I check first? So I have to go inside the port config. Yep, you're doing a capture, and if you see from port 1/7, the traffic what I see is CDP values here, nothing else. So I am on switch 2 over here. I'm on switch 2, and I'm going to check the basic configuration on port 1/7 because that is connected to this guy. Access port. Show running config interface fast Ethernet 1/7. If you see, there is no config. So the very first, the very basic configuration, it should be on VLAN 20. Switch port mode access. I'm making this as an access port. Only single VLAN traffic will go through this port. Switch port access VLAN 20. And also I have to check my layer 2 VLAN. The command is to check show VLAN switch. So it is active, and if you look at this, it is bounded to fast Ethernet 0/1 over here. This is on VLAN 20, V20, VLAN 20, access port, single VLAN 20, tagged. And now let me generate a traffic from VPC2. So again, it sends a DORA process. You see, I see the DORA process, and I'm not receiving offer packet from the server. So it's telling that I can't find the DHCP server. Where could be the problem? Let me hop onto the router. If we give show IP interface brief, exclude unassigned. If I go over here, show run interface, fast Ethernet 0/0.20, there is no IP helper. That's the first thing. Before that, do I run any DHCP services locally? If you see, I don't have any network for 20. So that's the reason this PC is telling that I don't find, nobody's responding for me. So what happens here, this guy, he's sending a discover packet. So I'm not receiving any offer packet because there is no DHCP pool configured here, or either I don't have an IP helper address here. So For my discover broadcast, nobody is responding. That's the whole point here. So this, when you're troubleshooting, these are all the key values you should check. DHCP, if you understand the basic fundamental parameters of DHCP, you can troubleshoot any kind of DHCP. So the first thing is you should have your DHCP server locally, and it should be in the proper VLAN, and the port should be trunked, because we covered most of the classes. You guys are, I am very confident that you guys are well versed with trunks, access ports. So this port has to be trunked, this port has to be access port, and I should properly configure my gateway, and it should have the proper subnet mask, and I should have a DHCP pool configured. If it is not locally, then wherever the DHCP helper address is configured, I should have all my IP parameters properly configured. That's it. So if you go back here for my discover packet, I'm not getting a response because either I haven't configured DHCP locally, or there is no DHCP server at this point for this particular subnet. You can see the source all zeros and destination is 255. It's a broadcast, and the layer 2 broadcast is happening. So it means that my tagging is properly done, and you can see the port, the source port is 68, and the destination port, the server port is 67. So it's trying to communicate over that, but the problem is there is no DHCP configuration for it. You can see that in the option 53, it is a discover packet, and also you can see the host name. The host name is VPC-21. I am telling, host name is very, very important. When you're troubleshooting something, host name helps you to figure out, okay, where the request is coming from, who is the user. From the very common generic troubleshooting, when you do from the common DHCP server, this host values helps you a lot when you do a troubleshooting. And also you can see the client MAC address. So it's something 6808. It shows your MAC address. So that's it about troubleshooting the DHCP and the DHCP relay. So when somebody is asking a question, you should say DHCP relay is a unicast, as we discussed. It will go like that, and you can explain all the values, what all the parameters you see, everything. We discussed a lot about DHCP. So now going back to the presentation, okay, no, I mean, sorry for that. So we have few more things to do. So how the packet behaves when I do a renew and release. So if I go to the VPC over here, this PC, because we properly configured DHCP on it. So when I say DHCP, something I tried, okay. Yep. I mean, this is something I want to show you guys. I mean, so when you do a decode on this VPC, it's actually showing all the what are all the values you see on the Wireshark. It's showing, but in the real computer, it never, you never have this option. So it is showing your lease time. You can compare your values, but in the real device, again, I am telling this is not possible. You can see your gateway. You can see your helper address. The same thing. Wireshark decoding it is doing only for the DHCP, not for TCP protocols. So your gateway it shows, and your renewal time, your rebinding time, it has an offer packet. So you will get a lot more information. If you definitely explore this, you can master your DHCP topic. So fine. So now let's do a renew and release. So IP DHCP, and if I give a question mark and I'm trying to do a renew, before that, let me stop and start the capture again. But my packet is still running. Okay, fine. So, okay, I don't know. This is on VPC2, probably. Let's stop capture, start the capture, Ethernet 0, open. hop on to VPC, I do a renew. So here is again one more interview question. So when you actually do a renew, it is doing the DORA process again. If you look at that, it's going through the same DORA process and it is sending the gratuitous R. So renew is something it is trying to re-establish. I mean, it's trying to renew with the same IP address. So it got the same IP address, 10.0.0.3. If you scroll up, see, I got the same IP address, 10.0.0.3. It is a renew. So it is telling that you give me this IP address to me again, even though it sends a DORA process. So when actually the renew happens, because we see the renew time here, right? So this is the least time. When we do so least time. So this is 86,400 seconds. It depends on the configuration, but after this, it will try to renew. So the least time is okay. I am giving you a 12 hours of time. You can use this IP address. So after that, it has to go for the renewal process. So, but this is something we are doing a release and renew manually. Yeah. If you do this, say, I'm going to release this IP address. I don't want this IP address, and I'm going to renew it again. So packet capture stopped with 100%. Let's start capture again. If you see, I see this DHCP release packet. So whenever you're doing troubleshooting, as I said, when you do this capture right over here, see from the source now it is 10.0.0.3 and the destination is 10.0.0.1. So it is clearly telling that my packet is a release packet here. Yeah. Earlier it is a DORA process, but if you look at this option here, release, it's something it goes with the same IP address. So it is telling that it is a release packet. There is no DORA process for release. And somebody is asking a question, then you should tell this. Renew is again an unicast. And you should see only the release packet here. Where the source has the same IP address, client IP address, and destination is always your gateway. And this is coming from VPC1. So the requested IP address is again 10.0.0.3 and my DHCP server is 10.0.0.1. If somebody is asking a question, okay, where you can see and what IP address the client is requesting for, it is an option 50. So if you give the enough details of DHCP, you can definitely answer any kind of DHCP question when you do this lab practice. So coming back to this presentation, you can see when it is rebooting. So it sends an offer packet. It will do a DORA process, discover offer requesting an acknowledgement. And if it is a renewing again, we saw this, right? Renew, if you look at this diagram, it is going for a DORA process again for renewing. So if it is expired, it is trying to rebind. It starts we saw that release and renew. So it is for rebinding. That is all a different option. So the key thing you should understand is uh, it is release, renew, and in the renewing, it's try to renew the same IP address. And you can see the transition diagram. So after the reboot, it goes for the DORA process again. If you do a release, it is doing a DORA process again. So when you do a release here, if you see -X stands for release, it sends one single packet. When you do a renew, it sends again a DORA process. So release is a unicast and renew is a broadcast again. That's it about the DHCP. So in the transition diagram, you can go through, you will understand the same thing. It is going for the DORA process, and if it is a release, it is an unicast renewal. So if you see this unicast request, right, for renewing. So this is about the DHCP deep dive. And now let's jump on to a different topic. So we have a topic for ECN and CWR. So as I said in the beginning of this class, you guys really should have a good understanding about sequence number, acknowledgement number to understand this. Hopefully, yeah, we are going through this journey very well. And I hope everybody understood all the options in TCP. So to do that, let me give you a simple visual to understand better about the congestion. Let me go to the TCP option. Let me drag this away. If I do a congestion, yep. So the three-way handshake typically refers to the process of establishing a TCP connection. However, when you mention the explicit congestion notification and congestion window reduced flags, the true additional flags, apart from your SYN-SYNAC ACK, there are additional TCP features related to congestion control and how we're going to figure out and what are all the scenarios where exactly these two flags are being used. So in the context of a TCP connection establishment, which involves ECN and CWR, ECN stands for explicit congestion notification and congestion window reduced CWR. During the three-way handshake, ECN can be negotiated if both the client and server support it. So it should support on both client and server. Once the connection is established and the data transmission begins, if congestion is detected through ECN, it is telling that explicit congestion notification it sends. The sender may receive CSR signal from the receiver. So now the receiver is sending this CWR, prompting it to adjust its transition behavior, like reducing the transmission rate by adjusting the congestion window. We'll see this in the lab. But the key point is if the sender may receive a CWR signal from the receiver, so it has to reduce the window size. It is telling that generally the sender is telling that, okay, so my window size is less. Now I'm in a congestion. I cannot hold much more data. My buffer is reduced. It's actually a congestion happened here. So I cannot receive more data right now. So you have to reduce your, I mean, the amount of data what you're trying to send, and you have to be, little patient. You have to reduce the amount of data what you're sending. You have to reduce your data because my window is reduced now, compressed. Therefore, the three-way handshake ECN and CWR are complementary mechanism in TCP where the handshake establishes the basic connection and ECN and CWR enhances congestion control during a data transmission. So CWR is a TCP congestion control mechanism that is used in conjunction with ECN. When a TCP receiver sets the echo flag to indicate congestion, the TCP sender responds by reducing its congestion window to elevate congestion. As I told you, if you understood the three-way handshake, definitely we will understand this. No problem with that. I'm pretty sure. Now going to the diagram. So this is the sender and this is the receiver. My router or any layer 3 device that is in the middle. So now not only the SYN-ACK and SYN-ACK flags, additionally I set ECE and CWR flags. We saw that. I will show you why this is written as ECE there. Is explicit congestion notification and congestion window reduce are these two flags. When I set the receiver sets these flags, once the receiver receives this, in the first three-way handshake, it doesn't mean that there is a congestion. So that's the key takeaway here. So during the three-way handshake, if both sides supports this mechanism, only then this congestion control works, not for all the application. So we have a scenario where we will check, we will see how in the three-way handshake this three packets are exchanged between source and destination and how it exactly the congestion window works. Let's do that. Let me open the capture. Let me drag this up. Let me take my pen. So this guy over here is the source and this is the destination 1.1.23.3. And we all know this SYN, SYN-ACK, ACK or the common three packets that usually sends in the normal packets. But when you open this is a very first packet, SYN packet, right? I saw the three-way handshake successful over here. So I'm going to open the very first packet from the source. If you see, the source is this guy 1.1.23.3 and the destination is 1.1.12.1. And if I open my flag, it's telling that I set ECN echo and congestion window reduced. Yeah, this is enough at this point. So I send this. Also, the receiver is telling that I do support these two. So I do support ECN, I do support congestion window reduced, right? But right now, there is no congestion. The three-way handshake happened and it agreed on both. And so when it sets the ECN, explicit congestion notification, so it means that whenever there is a congestion, I'll tell you there is a congestion. So when you see this flag, that is actually married together, this congestion window and ECN. So if you set the ECN at this point, so I support congestion window. That's the whole meaning of it. So this is the sender and the receiver 1.1.12.1 over here. It is sending the ECN packet, but there is no congestion at this point. Got it? So this source 1.1.23.3, let me write this. This is client. Delete this. So this guy is a client and this is the server, right? This is client and this is server. So now I'm going to the client. So this is the client, right? Now I'm going to the client. And if you see, the client is trying to do a GET request. HTTP protocol is used. Port 80. If you look at this in the three-way handshake, you see this is port 80. So at this point, if you actually see, it is telling that, can you send me 162 bytes of data? It is acknowledging it. So it sends the 162 and it is incrementing. And if you see, can you send me the 257 bytes of data? Yes, I will do it. Then again, it is telling that, can you send me 162 bytes of data? Can you send 538 bytes of data? And if you actually see this, it is giving a TCP window size. It is giving an update, right? Then again, come down. At this point, there is no congestion. Let me delete this. So, right, we are on this packet. We are coming down. Again, I see TCP window update. And in every TCP window update, if you actually see, it is reducing and it is going back again to the same sequence number before that it is reducing. After this Windows update, if you see, my packet count reduced to 162. Then again it is increasing, then again it is reducing. But where exactly my congestion happening? So in every TCP window size, it is proposing a value, right? This is a sequence number and this is an acknowledgement number. And if you drill down, how exactly I should spot there is a congestion? If you look at this particular packet, the difference is when you compare these two packets here. Over here, there is no congestion, but right over here I see congestion. If you actually see this, the packet jumped from 16,572 bytes to just 162 bytes. So again, it is going back again to the same 162 bytes of data after this Windows update because it is telling that I have a congestion. If you compare the previous values here, when the congestion happened, the packet sizes keep reducing. And if you exactly go over here, exactly here my congestion happened here, right? And you see the packet, the sequence number is 162. It reduced back. From if you look at these two values, the cross values over here, 18180. So it's proposing that I can accept until 18180, but it is sending a TCP window size. And when it starts the congestion, so here is a threshold reached. So this is like a graph. So my traffic is going, and it is going well, and my traffic is dropping. Here exactly the congestion window works with the flags. And again, it is proposing with the Windows update, it's all going well. It's the you know it's peaking again and it is dropping. It's peaking again and it's dropping. So here may be a question why this happens. If this is not happening, this is the best way to reduce your congestion. If there is no such mechanism, what happens? Whatever the packets I'm keep sending from the source to destination, there will be a congestion and your packet will be lost in the middle, right? There will be a huge packet loss. To control this, TCP maintains this beautiful mechanism to control this. And if you open this, who is proposing this CWR value? So if you go back to 1.1.12.1, that's the destination, right? So whenever if you see a congestion window, I would suggest you should mark a packet something like this. Even if you go anywhere, if your packet is marked, it stays right on the screen. And if you open the capture, so my source is this guy. This is actually, if you go back to the very first packet, 1.1.12.1, that is the destination. D stands for destination. This is source. So it is telling that there is a congestion. You have to reduce, right? Right over this, you can see this. So whenever there is a congestion, so again, if you look at this, there is a congestion in the destination server. Again, it's giving out a CWR value here, congestion window notification. So we have to work on it and we have to reduce. And if you actually see the amount of data right over this TCWR, it's again furthermore reduced to the very first sequence number. So this is very, very important, guys. So how much data you send, so that is decided by your sequence number. That's very important. If you see the very first packet is after this, all this ones, right? If you see, this is the acknowledgement it sent for this 162. So when you're going back to that, that is your tipping point. So this is my tipping point is 162. Sorry, yeah, 162, and it keep increasing, whatever it may be. If it can be 18,000 or 19,000, my dipping value is 162. If there is any problem, so it starts with 162, very less amount of data as like before the very first packet. If you drill down, this is the total amount of packet. You can see we started from 162. We started from 162 and we ended up with 83,400 total amount of data. So see the final packet over here, it's telling a acknowledgement for 83,400 and it sent an 83,400 bytes of data in total. Whenever you see a congestion, you see the values reducing back to the initial sequence number value. You can see everything here. This is something you should understand. Whenever, so here, the 1.1.23.3, right? This is sending the congestion packet here, ECE. So when there is more congestion, and it explicitly telling that, you see this CWR value here. See, because of congestion, it is sending very less packet. So you have to figure out who is sending the most congestion window packets. Where there is a congestion, you have to figure out. As I told you, if you open this capture, here actually you can find most of the values, see lot of Windows update. So whenever you see lot of Windows update, there is a congestion. And as I told you, you have to go packet by packet by packet to figure out who is sending. If you look at my packet, most of the packets all coming from 1.1.23.3. You cannot conclude with one packet, right? You have to go packet by packet by packet, and you have to count, and you have to do an analysis, and you have to figure out. If you give IP dot address 1.1.12.1, it's going to filter all my 1.1.12.1 packet with all the conversation. So for now, the whole ideology of this particular topic is to understand what is congestion window. Let me open the presentation now. So now you guys can understand better. ECN is a mechanism that operates by setting a flag in the IP header to indicate congestion to the host. And CWR is a TCP congestion control mechanism that is used in congestion with ECN. So that is married together, ECN and CWR. So this should support on both sides, sender and the receiver. And along with that, we discussed about the window size. So if it is a zero window, as I told you, there is no space, no buffer. indicates that receiver buffer is full and it cannot accept more data. When the receiver advertises zero window, the sender must pass data transmission until a non-zero window is advertised. So sliding window, we know if there is no congestion, it keep increasing. We discussed this in the previous classes. Window size is something, it's a scaling factor, right? Sliding window, we discussed that. Okay, when I mean, so sliding window is a slight different. I mean, I missed that, so I'll rephrase the sliding window. Sliding window is that if I see a continuous acknowledgement, it doesn't mean that I want to get an acknowledgement for every single sequence number, right? We saw that it can jump from 62. If you look at this example, we discussed this before. It can jump from 162 to 257, but it doesn't mean that I have to get an acknowledgement for 163 to until 256. No. So I received this amount of data, so I'm going to send an acknowledgement for 257 and it's going to send a data for 257. So if you see this, I send an acknowledgement for 538 and it is sending the sequence number of 538. 538 bytes has been sent now. And it is telling that TCP window update and it's sending an acknowledgement for 538. Once it's sent, so it started reducing, right? So it started again from the beginning, 162. And if you see, it's again sending an acknowledgement for a small amount of data. So for these two acknowledgement, I got a packet 162 over here. So the key thing here is we should understand what is TCP window update and what is congestion control and what is ECN. Then with multiple capture, I'm pretty sure that we will understand what is congestion window. So once this is CWR is advertised, you can see that it's jumped back and it sent a packet for just 162. So again, with the TCP window size, it starts from 162. So the whole point is it is very dynamic. TCP is very dynamic. It is not that I am keep sending your data like UDP and it is receiving it. So that is a mechanism we should understand about the congestion control. So without this congestion control, definitely we see the packet loss. But if you see here, there is a congestion, but there is no much packet loss. TCP dot analysis dot flags. We have this filter. You can see all your TCP window update. So if I cancel this filter, so the congestion happened on both sides. My final conclusion for this particular capture is TCP dot analysis flag. The destination is 1.1.12.1. And if you see, all my TCP window update is sent by my source. So you guys tell me in the chat where exactly the problem is with this capture. So that's it about the congestion control. So with this, we have covered all the topics in TCP. Then let's jump back to LACP. So link aggregation protocol. So to do that, let me open the whiteboard really. We will finish it very quickly. Let me go to my pen. Let me delete this. Yep. So right over here. So I got a core switch. Very simple topology. Will take just two switches here. So I have an uplink connection like this. And if I have one more parallel connection, if it is running like this, so the problem of the spanning tree, I will not say problem of spanning tree. The protocol, the mechanism of spanning tree is to block the redundant port. So here it considers, okay, this is fast Ethernet 0/1, and this is fast Ethernet 0/2, and over here this is fast Ethernet 0/1, and this is fast Ethernet 0/2, and it thinks that it considers the lowest port ID, so it elects this port, and it it's going to block this particular port because it has the highest port ID. So to avoid this, I want to increase my throughput. If I want to increase my packet flow, so I'm going to bundle this. How to do that? So here comes the LACP protocol, link aggregation protocol. So it is aggregating the ports logically. So it is going to define a name called as port channel. So here is this very important, the best practice of port channel. You guys would have done that, but from the troubleshooting standpoint, I would better take a notepad for this. Okay. So when you configure, when you bundle the port, example, if I have two ports, interface fast Ethernet 0/1, and if I got interface fast Ethernet 0/2, these two ports going like this. And let's say this is switch one, and over here it's switch two. It's the same port, right? Let me copy this. So this is switch one and switch two, and in the middle, port channel one. So when you configure the port channel, so fast Ethernet 0/1, first thing it should be trunk, because if it is not trunk, it will not allow your VLAN. So example, I allowed the VLAN 40, only one VLAN for in this example. So the configuration should be identical on both the ports. And along with that, it's going to create a logical interface for you that's called port channel. And there you should have the same config. All should be identical. It applies for both switch 1 and switch 2. This is very, very important. Otherwise, your port channel will not come up and your LACP never works. So when you're doing your troubleshooting, the very key thing you have to see is whether you have done a trunk, and have you done the trunk on all the ports. And along with that, you're going to tell channel group any number It's a dynamic number. It doesn't mean that it has to match on both switches. So the channel group one, you can configure on switch one, you can have a channel group one and you can have a channel group two on the switch two. But in this example, I'm giving for the both switches, we have the same config, same port. So channel group one mode active. I'm telling that actively I'm listening for LACP. So when you enable this active, that actually kicks in your LACP. So it has to be again configured on actual physical interface. The first part here, so I configured is active. So the other side here for the switch 2, if we go over here, the only change is what I have to do is channel group passive. You can think this is a plus minus. Active is plus, and the other side should be minus. Also, you can do a configuration like active, active, that works. Active. If you give active over here, it works. So this is a recommended configuration. And you should enable this channel group. You should enable the LACP on the physical port, not on the port channel port. You have to enable only the trunk. So what are the key commands for troubleshooting? Show ether channel summary. And your port should be bundled. It should not be in suspended state. Say for example, if you configured VLAN 40 here and if you configure VLAN 40 and 30, your port will be suspended because the VLANs should be identical. So when you think these two ports as a one logical port, all the configuration should remain same. You should not change. Whatever the VLANs you allow, it should be same on both ports, both side bidirectional. So if I allow 40-30, VLAN 40-30 here, and if I allow only 30, your port channel will never come up. It will be in the suspended state. So now let's jump back to the lab and let's do a lab. So if you look at here in my diagram, I created these two switches. So I made one, the whole port logical port. Now it's logical from the spanning tree perspective. It is one single port. It's going to show this port as a one single port. So in the spanning tree, if you do a trunk on this port, the expected thing what you should see here is the trunk port is port channel 1 and not Ethernet 0/1 and 0, because now you bundle logically. So spanning tree is going to look this port for these two ports. It renamed the port as port channel 1. I mean, not spanning tree. We did this using LACP. So spanning tree is going to see this port as a one single port. Okay, port channel 1, and I see the VLANs going through it. And I'll show you the config. If I go to switch 4, if I do show run interface Ethernet 0/1. So if I look at this key values, you should focus on is, so I enabled trunk and I set this channel group mode active. Since this is an open trunk, if I give show interface trunk, so I'm allowing only VLAN 40 over here. This port, right? Port channel 1. If you look at this is the port going to, if I give show CDP neighbor, because you cannot see the topology in the real network, right? So if you look at this, the actual ports are Ethernet 0/1 and 0/0. These two ports. Let me use a different color. These two ports, right? It's going to, this is telling that the output of this, you can do, instead of CDP, you can do LLDP. I think this will never support LLDP. LLDP is open standard, CDP is Cisco, so I'm trying for LLDP. If I give LLDP run, and you should be on both devices. Let me go to switch 6. Show LLDP neighbor. I don't think it works on the Cisco box. Let me see. Okay, so yeah, we'll focus on that now. Let's finish this lab. So Ethernet 0/1. So this is a local interface. It is telling that this is my switch 6. Sorry, this is a remote device, switch 6, and this local interface belongs to this guy, switch 4, Ethernet 0/1 and Ethernet 0/0. And it is telling that since this is IOL, it is showing Linux, but in the real device, it will show you the actual device. And if I go back to the switch 6, so this is a basic connection you should check. Show CDP neighbor, it is telling that the remote switch, the first value, whatever you see over here, this is your remote device, switch 4, and the local interface is this guy over here, Ethernet 0/0 and 0/1 on switch 6. For him, this is the remote device, switch 4. It is telling the ports. And even in the LLDP, same kind of output, you should see this is capable of, this box over here is capable of, R stands for routing, S stands for switching, and this I stands for multicast. It's again out of topic. So this device it supports switching and routing. That's the whole point. And what else I have to check? So if I go to show run interface Ethernet 0/1. So I did this right. I enabled LACP right over here. This ports LACP. I enabled LACP over here. I enable LACP on the physical ports. And then if I give show IP interface brief, exclude unassigned. Let me go back to the switch 4. Show run. Show IP interface brief. If you look at this is port channel 1. And one more thing, very important. There are two types of LACP. One is layer 3 LACP and layer 2 LACP. Layer 3 LACP is something you assign an IP address to it. Layer 2 LACP is just you are spanning the VLANs. So L3 is a routed and L2 is layer 2, no routing, only switching. So you allow only the VLANs on it, but it is an layer 3 port channel. You can assign an IP address to it. As simple as it is. So now we are focusing only on layer 2 LACP. So we are checking the configuration. So we check the physical port config, and if I go to the port channel, show run interface, port channel 1. So if you see, I enable only trunk, and as we discussed, there is no way, I mean, there is no option to create, I mean, there is no way to enable your LACP on the logical port. So LACP should be enabled on the physical port. Only the port channel should be the trunk. T stands for trunk. Should be same on both. So what I am telling basically here, so it is a trunk port. I made this as a logical port. Now it becomes a trunk, and I am allowing VLAN only. I'm allowing VLAN 40. So if you do show interface trunk, you can actually see you're allowing only 40. If you see the port channel 1, that goes to switch 6 right over here. So Ethernet 0/3 goes to this switch. And now let's do a capture. So to generate a traffic, I'm on switch 4. So I'm going to run a capture. And if you see, you cannot see your LACP packets. You cannot see that port channel port. You know that that's a logical port. That's not a physical port. So if I do Ethernet 0/0, and then if I go back uh, here to switch 4, so we have to run this command, show ether channel summary, as we discussed there. So P stands for bundled. It should be bundled. So it is telling that basically I bundle the port 0/0 and 0/1. And what if I do interface range Ethernet 0/0-1? So it means that from 0/0 to 0/1, I'm going to shut down this port. And if you go back and see your status, show ether channel summary. So D stands for down. My port channels are down. And if I stop my capture, so it is telling that the LACP packet, right? It's my LACP. So if you do LACP right over here, you will see that so we can check the MAC address. So where it is coming from, 5000, show interface Ethernet. Ethernet 0/0. So this guy, right? I mean, if you look at this, my switch 4, this is my switch 4. sending this LACP, and this guy again 6000, the remote device, switch 6. If I go back to switch 6, show interface, I think it should be the same ports we have. Ethernet 0/0, show interface, Ethernet 0/0. So if you see this 6000, so this is switch 6, right? Both are sending an LACP. And if you open this, you can see a different set of a I mean the flag values here. So LACP is active. It is ready for aggregation. All these default values are enabled here. So it sends in synchronization. It's telling that it's an active. This is the default priority values. These are all the key values. I mean, this is not something we should focus much, but we are just seeing the packet exchange here. We'll do a deep dive about LACP, but whole point now is how the basic LACP works. So both devices is trying to do an LACP negotiation, but it is not happening, right? Let me stop this capture. The buffer is filled. Let me do a capture again. So let's run a capture again. It's not working. Okay, it's working now. Ethernet 0/0. Open the capture. Going to switch 4. We know this is switch 4. Right over here, I am on the CLI of switch 4. Config. Interface range. And if you actually see this thing, show IP interface brief, the port channel is automatically down. I didn't I mean, I didn't admin down this interface. It went down automatically because my physical ports are down. So if I go to interface range command, Ethernet 0/0/1, no shutdown, and we are running the capture. So let's run couple of commands. Show Ethernet. So Ether channel summary. So now the port is bundled. And this is what exactly I want to show on that day. Okay, so we'll discuss, come back to that. Okay, so so now the ports are bundled, and if I do an LACP, actually do LACP. So from here, we know that 600 is let me write this again. Switch 6 and switch 4 are talking. Both are sending the LACP messages. If you see, this is telling that this is the LACP activity is passive. So if you look at this right over here, it turns into an active state. So it means that we are making a neighborship with that. So you don't confuse this option with the configuration what we are doing there. So generally the key values we have to see is the LACP I have to receive from both source and destination. So how do I spot that just with the MAC address? I should see this on both sides. So when I'm doing a capture, yeah, I should see the LACP packets coming in from both sides. We'll do a deep dive about other headers tomorrow. But for now, if my LACP is working in from the Wireshark, the basic checks, as I said in the command lines, you have to check everything. And after that, you have to come right over here and you should see the LACP negotiation happens from both switch 4 and switch 6. I'm differentiating with the market risk. So, and one more thing, I told you I should show you the TCN packets. On that day, we try to replicate in the labs. So whenever there is a change, so now actually we bounce the port and you can see in the spanning tree, we are just allowing VLAN, only VLAN 10, right? We give show VLAN. So we allowed only VLAN 40, both on switch 4 and switch 6, no other VLANs here. So in the spanning tree, it is telling that, okay, the only VLAN allowed is VLAN 40, and there is a topology change notification. If you open your spanning tree, so you should see this, your BPDU. So as I told you, it sends a BPDU packet whenever, it keeps sending. But here in the BPDU, it is telling that I'm sending this topology change notification. There is a change in the topology. The port is bounced now. If you look at the other normal BPDU packets, we'll look at the other headers here. In the exactly in the topology change notification, the BPDU packet, it is telling that topology change notification. So it is acknowledging, right? Topology change acknowledgement. It is telling, yes, I acknowledge this. Yes, there is a topology change and we do agree. So all the switches in the spanning tree, it should agree upon this topology changes. So the BPDU flag set is topology change, and you will see a separate packet there. Exactly, you should see this topology change notification irrespective of your bouncing your port, you're changing your LACP. So this is something I wanted to show you guys about the topology change notification. Since now we changed the port and the VLANs is being propagated, and it's telling that only only the VLAN 40 is allowed, and this is topology change notification because recently there is a change. So for him, it sees that there is a change in the port transition. So that's it really about LACP. So now I'll come to this. Okay, that is a good question. I'll answer this. Let me give a mute permission, everyone. Before that, let me stop sharing to unmute yourself. 1 minute, and then let me stop this recording. So guys, if you have any questions, you can ask me. Emuna. Okay. I think he left the meeting. So suppose fast Ethernet. Let me share my screen. The question is, suppose fast Ethernet 0/0.10 configured with secondary subnet as well. How this will work? The secondary address only works. The secondary subnet works only if your primary subnet goes down, because that's your secondary address. And in few cases, I have seen if you have a PC configured for that particular IP address, but that's not actually a best practice. Yep, I mean your secondary IP address is different, your primary IP address is different. I think your question is something we have an option to configure the secondary IP address in the interface. So whenever there is a broadcast happens, it always look for your primary subnet, not the secondary subnet. So that's a whole that's a whole purpose of secondary IP address in the router port. So guys, do you have any questions?
Hello.
Hi Ali.
Hello. I have a question regarding DHCP. So
Mm-hmm.
in the real environment, let's say in my PC,
Mm-hmm.
and I don't know where does the DHCP server located.
Mm-hmm.
Do and I have the gateway as a switch. Okay, my gateway is a switch.
Mm-hmm.
So in the switch, do I identify the DHCP in the switch?
Okay, so your question is you have your DHCP somewhere else, but you don't know, but
Yeah.
you have to find. Yeah,
Yeah.
absolutely. If you go inside the configuration right over here, if you see this scenario,
Mm.
um, I don't know where is my DHCP. So that's a scenario as you asked the question. So if I go to show IP interface brief, exclude unassigned, and if I go to show run interface, fast Ethernet 0/0.10. So even though if I don't know that DHCP IP address, this is my DHCP IP address 20.0.0.11. That's a physical device. That's the whole meaning of this. So now, since we are running the DHCP server locally, this router behaves as a DHCP server here. But in the real environment, if you define this is your DHCP server. Example, this device over here, this is your DHCP server VPC4. You have to give the VPC4 IP address over here and the IP helper address. And on that particular device, you should configure your DHCP pool.
Does it need any routing here?
Yeah, absolutely.
Oh.
If you have no reachability to 20.0.0.11, then your DHCP discover will never, you will receive an offer packet back. IP is the basic communication. So DHCP comes in your layer 7, right? It's an layer 7 protocol. So if your IP communication is not happening, apparently your DHCP discover packets dying in the same device, right?
Got you. So can you go back to the Wireshark, please?
Hmm. I
Okay,
mean, this is
you
a
were
different capture. We
yeah, you were discussing regarding the Windows update. I need to see whenever we have the congestion, how
Mhm.
we read the bucket, how we read the logs there. Once the bucket is peak and once it's going down.
1 minute, let me open the capture. You're talking about this capture?
Yeah, right
Uh-huh.
here.
Uh-huh.
See, can you highlight to the acknowledgement there?
Mm-hmm.
So this is the start of the traffic, right?
Conversation,
Yeah,
yeah.
yeah. So you see the one there on the top.
Mm-hmm. The first
This is,
packet.
yeah, first packet 0, right? The
Mm-hmm.
acknowledgement,
Mm-hmm.
and then send in 1, right?
Sorry, I didn't follow you. The first
Okay.
packet is SYN, so this is SYN-ACK, yeah.
Yeah, I'm talking about the bucket,
Mm-hmm.
the bucket. You see, like when the bucket is when there is any Windows update,
Mm-hmm. Here, yeah.
and there is a congestion.
Mm-hmm. Yeah.
Yeah, so you see 538.
Mm-hmm.
So this is the bucket size.
No, I mean, we discussed this, right? So this is the acknowledgement fields. It is telling that can you send me the can you send me 538 bytes of data?
Mhm.
Because my it is just doing an acknowledgement. It doesn't mean that the buffer size is this. The actual buffer size is if you look at your TCP window size is actually your buffer size. So this is your buffer size. So I can hold up to 4128 bytes, but it is acknowledging this 538.
Okay.
It is for this now, based on the conversation and the user input, it is telling that my window size is 4128.
All
It,
right.
it is proposing that the whole buffer is 4128, but your actual data is 538.
So it does segment here, right?
Yeah, correct.
Okay. All right. Got it.
Yeah.
Thank you.
No problem. Yeah. Any further questions, guys?
Sir Praveen.
Hi, Raju. Yeah.
Hi, Sir Praveen.
Yeah. Yeah.
I have one question for not part of it. Uh, Recently, 2 days back, I have faced one issue in my organization. My topology three-tier architecture in my organization for distribution access switch. So here the issue in one switch, all the ports are working fine, but except three ports are not working. The three ports are associated with some other VLAN, the camera VLAN. So
Okay.
only the cameras are only three ports. The cameras are down. When I checked on the switch, the interface status is up, but physically the cameras are down. Uh, so when I have assigned the camera IP to my laptop, even not able to ping my the camera IP. So I have resolved when I shut and unshut the uplink port, the issue is resolved. But still, I don't know what is the real cause of this issue, because here we have two switches connected via stack.
Okay.
Do you have any idea? Could you please tell me what is the real cause? Why
No,
the three
actually,
ports are not working?
from partially, I mean, I got it, but I don't know. Since you said the uplink port, once you bounce the uplink port, it
Yes, yes.
started working. But have you checked the particular VLANs? What you're talking about? The three ports, the faulty ports. Have you checked the VLANs as actually, traversing the switches? So it can be a core or the other remote devices. Is it that your VLANs are allowed? Or maybe I'm not sure if you said you after bouncing the port it worked, or maybe the trunk port is down, your main core switch port is down. There will be multiple reasons here, right?
Because
When you
yes,
ping where you're trying to ping before to that three problematic IPs, from where the source is coming from. So all the ping you're doing is within the same LAN or a different LAN.
yes, different LAN.
Mm-hmm. But
Because of other VLANs are working fine.
mhm.
Those are traversing via core. But
but
here the issue is only camera VLANs only.
but the camera
Yes.
VLANs can be reachable from other VLAN gateways. The inter VLAN communication is happening.
Mm, I did not check that one.
Yeah, the very first thing you have to check is when there is a example. See, here, if your VLAN is VLAN 40, if I'm trying to ping from VLAN 10, first I should reach VLAN 40. Only then my inter-VLAN communication is perfect. So when the packet reaches until VLAN 40 gateway, so my
Okay.
VLAN 40 works fine. There is no problem with the spanning. And from VLAN 40 to that particular PC, if you cannot ping, you can try to establish a connection with the source port of VLAN 40, your layer 3 VLAN 40 to that particular PC. If you try to ping, if you can ping or not from that source as a source as a VLAN 40. Have you tried that?
I have tried the gateway of the camera IP, camera gateway. Even when I try to ping the camera gateway, I am not able to ping. I am getting request timed out.
Okay, if the request time route is happening, is that so your routing from source to destination is happening, but the destination is not responding back.
Yes.
So have you checked the subnet details? Is it your subnet details is properly
All
configured as
are,
per your gateway? Is it your gateway is
yes,
properly configured?
yes, properly configured.
Can you do
Even
it? Have
I have assigned the same IP to my laptop, the IP and subnet mask gateway. Even I am not able to ping.
have you
It is
checked your VLANs? Is it the VLAN access ports are properly configured?
no, sir. I did not check that.
You have to check the access ports. Is it your access ports is the main? I mean, if your layer 3 VLAN is good, the only way for your communication is you're in the trunk. You should allow the VLAN. The other than that, your actual access port should be properly configured to that respective VLAN.
This is the stack switch. Is there any chance to block STP spanning tree?
No, no, no.
No, because we did not do any changes recently. Suddenly, the three cameras are down. Only that particular VLAN on the same
Uh,
switch. Remaining all other switches are working. All VLANs are working. Only one switch. The three ports are down.
how long it is flapping in? As you said, once you bounce the port, it started working. Is it the same problem happened again, or it is pretty
No,
stable?
no. It's not happening.
Hmm. We have to monitor. I mean,
Okay.
you have to check for show logging output for your syslogs if you get some kind of insights to that. And also you can check your port security configuration. Maybe your port security sometimes, if you unplug a device into a port, if you do a static reservation on it, if you connect any other device other than your, configured MAC address, say for example, if you configure this port as a port security, you know that, right? I mean, if you connect
Yes,
the
yes.
other device to
Now,
that, your port goes down.
yes, sir.
And you should check show interface status error disabled state. If you see that if it is an error disabled state, you have to bounce, because since you said it is once you bounce a port it worked, it can be a port security. Is it you guys enable the port security as a best practice for all the ports?
Already we have a MAC port security. Every what device we have connect to any port, we have sticky that port. The MAC
Yeah,
sticky already there.
okay, so are you guys swapping the cameras between the ports?
No. We did not do
You
only.
you check the logs. Do you see any kind of
Yes.
violation counts on that particular port? You should see that. If somebody is swapping it, you should see, I think, show switch port security violation. I think if there is some, if any other cameras or if anybody try to connect other cameras on the same port, you should see the violation count increasing there.
Yeah, next time I will check that.
Yeah, yeah.
Thank you, sir, Praveen.
No problem, no problem. Thank you. Yeah. Guys, if there is no further questions, then we can drop off. Hi, Deepa. You understood everything today? Hi, Mario. You're good?
Yes, all fine. This is not new. I have been working with the Nexus switches,
Mm-hmm.
so I know the port channel very well. So also this part is quite clear, and yeah, but maybe in the next session, maybe would be but
Okay.
the protocols and also spanning tree, maybe I can
Okay.
I will ask you more
Uh-huh.
questions. This
Okay.
this part is clear. Yeah, thank
Okay.
you.
Okay. No problem. Yeah. So Raju, you're good.
Yes, sir. I'm good, sir.
Thank you. Suresh, are you good? Vijay, you're okay?
Yeah, Praveen, thank you.
Okay. Suresh, Vishal, you guys are all
Yeah, good.
understood? Okay. Cool. Awesome. Okay, guys. Good night then. We'll meet tomorrow. If you have any questions, let me know. I'm happy to answer your questions. Yeah. Thank you.
Bye bye, Brian. Thank you.
Bye.
Good
Bye.
night.
Bye. Bye. Good night.